Guys, at the beginning of each lecture, I used to say that in this lecture we will study this particular thing, but for the first time I would like to say that in this lecture we won't be studying almost anything. This is just for your information that whatever the content of this lecture is, most of the part we have covered in an earlier lecture, and some of the things that are not covered is not appropriate to be covered in this particular video. So what we will do is we'll go through this video and we will say what we have covered and where we have covered, and also what we have not covered and where will it cover it. And also the most exciting part is that after this video we will enter into a topic which is very sought after, especially for the exams like of course JEE Advanced, because we will be entering into a topic that will be revealed at the end of this video. So in the first slide we have the table which say that which compound is covalent in nature, which compound is ionic in nature, and which compound has an ionic lattice but is predominantly covalent. This we have dealt in maybe the types of solid video that you can see in the playlist, and so it's not worth it to cover it in this video again. Now we have the order of covalent character of these many compounds. I want to be able to give any reasoning for this particular order at this point of time. We will cover this when we would cover the color of the compounds, because these are in a way related to the color of compound, because as we know that as the covalent character increases, the darkness also increases. So we'll cover this type of ordering in the topic when we will discuss color of compounds. And one thing I would like to mention is say is that polarizability order. We have the polarizability order here and the reason is also given. So the polarizability order of PO4 3- is maximum, followed by CO3 2-, followed by SO3 2-, and finally SO4 2-. The reasoning is that as the electronegativity of central atom is increasing, that means the electron holding capacity of the central atom is also increasing. That means the electrons from the oxygen atom will be pulled towards the central atom. That means the electron density on oxygen atom would be less, and so the polarizability of the overall compound would be less. And this is the reasoning given here, and I can tell you the electronegativity value of central atom, En of central atom. So of phosphorus it is 2.19, for carbon it is 2.55, for sulfur it is 2.58, and for sulfur again we have 2.58. So you can see that as the electronegativity of the central atom is increasing, and so polarizability is decreasing. Now for SO3 2- and SO4 2-, the polarizability of SO4 2- is less, because we have 4 oxygen here. That means the electron density is more dispersed here, and so the polarizability is less in case of SO4 2-. This was the one thing that was to be told in this lecture. And now we have a note here that polarization of polyatomic anion is less than monoatomic anion due to delocalization of negative charge. This is obvious, as if there is any compound, if the negative charge is more, that means is more concentrated, that means that anion can be more polarized, that means its polarizability is greater. But in case of polyatomic anion, we have seen that as the electronegativity of the central atom increases, the electron holding capacity of the central atom is greater, and the polarizability is less because the electron density on the surrounding atom is less. Now we have another comparison here. Obviously we have learned that the polarizability of PO4 3- is maximum, followed by CO3 2-, followed by SO4 2-. So the covalent character would also follow similar order, because covalent character is directly proportional to polarizability, and the intensity of the color would also follow the similar order to that of covalent character and polarizability. And so the color of Ag3PO4, which is most covalent in these three, is yellow in color, and The least covalent, that is Ag2SO4, is white in color, and the intermediate covalent, that is Ag2CO3, is yellow white in color. Now this was all that was to be told in this lecture. Now we will enter into a very exciting topic, and which is most sought after, as I told in the beginning of this lecture. We'll be entering into thermal stability, and we will be looking into the heating effect and all for various kind of compounds, and what would be the product when a particular type of compound would be heated. And this is a very important topic.